Hey there, welcome back to Coding at Home. Hey there, I'm Matt from the Code Hub. Welcome back to Coding at Home. We'll be talking today about Sensor Arcade a little bit more that we've been working on the last few days. Today we'll be exploring using the microphone as our sensor, and we'll be dealing with the pitch of the sound that comes in over the microphone to control different players on the screen. But before we get to that, there's a couple big updates today. So there's a new version of Swift Playgrounds out that fixes a few bugs and improves a bit of performance for both the Mac and for your iPad. And there's also a brand new book out in the Everyone Can Code series. So we worked through Everyone Can Code puzzles a couple months back, and we've since been off the reservation working on the Sonic Workshop, working on Lights Camera Code, going above and beyond with all the different playgrounds Apple has to offer. Well, they now have a new book out called Everyone Can Code Adventures, and then it covers some of the same material. So we might go over some of that in future sessions. We've already done a lot of the playgrounds, but they've put together a really nice book that explains some of the concepts behind the coding that we've done already. That maybe will help it stick better than what we've done already to date. And it always helps to go over things multiple times, sometimes throwing in a little wrinkle here and there, just to get a better sense of the material. And we'll just plug in our network so we're performing a little faster. So what we're going to do now is we're going to jump over to the iPad. We're going to kick off an update for Swift Playgrounds, and then we'll go to the bookstore and show you the new material. So let's head on over. All right, so over we go. All right, so first things first, we'll go off to the App Store. We'll take a quick look by tapping on your own icon, and you can see when apps are available to be updated. So I've got a new version of Keynote and a new version of Swift Playgrounds. I'm actually just going to hit Update All here to update both. And so while that's going on, we can't use Swift Playgrounds. So we'll go back to the desktop here. You can see it's loading now. But we're going to go off to Books. And I'm going to go to the bookstore. You can see I've got a few here, but I'm going to go to the bookstore because if you likely don't have this downloaded just yet, as it just came out. And what we're going to do actually is go to search. And we're going to look for Everyone, we're going to spell it right, Everyone Can Code Adventures is what we're going to look for. And I don't want to search for adentures because that is looking for false teeth. Okay, so in the bookstore, we have the teacher edition and the student edition. We want to click on the orange cover one. And so the idea behind this book is that after we've done Everyone Can Code puzzles, this is our next step in our coding journey. So I'm going to hit the download button because I've already gotten the book. It's for free again. And if you don't see a download, you'll see a get button. And you can see from the screenshots that it talks about placing images. It talks about the grid a little bit more, so maybe some of these visual cues will help you more. It talks about designing apps that we talked about a little bit when we did our App at Home series, and we built an aquarium. It talks about Swift, a scene, and a view. It talks about arrays some more. We were pretty familiar with arrays by the end of Everyone Can Code puzzles. And then it talks about some augmented reality. So let's go see if that's downloaded. If it's downloaded, that button will change to a red. The other thing you'll see is it'll show up in your library. So you can go to Reading Now or Library. And I'm actually just going to search inside my library. Actually, I'm not going to search inside my library. I'm going to switch this from sort by author to sort by recent. And I'm going to look in my Everyone Can Code section. And I'll open up Everyone Can Code Adventures. So we can get to the table of contents up here again. We have a little introduction and it talks about what we learn in this particular course. You can see it looks very like Everyone Can Code Puzzles. And we have the different sections again, our learn, try, apply, and connect. And these are the playgrounds that we need to download to follow along with this book. You can see that we've done just about every one of them. We, of course, have played with Learn to Code 2. We didn't do too much with Blues Adventure. We did a lot with Lights, Camera, Code. We did a lot with Assemble Your Camera. We kind of skipped Flashy Photos. We can come back to that one. We did Sonic Workshop. We did Code Machine briefly in one of our look back sessions. We did Augmented Reality, and we're working on Sensor Arcade now. So you can see all the material that we've gone on to do since leaving Everyone Can Code Puzzles is covered in this Everyone Can Code Adventures book. So it'll tell you a bit about, for example, this first one is Objects and Views. Let's look at the table of contents again. And we can see we go from Objects and Views to Events and Handlers that we've been covering lately with Sonic Workshop, to Arrays, to more Events and Handlers, and this is where we try sensor handling, so that's where we are now, today. Functions is arguments, so this is try using closures, and that's where we learned about that a bit in Sonic Workshop, and we also use them in Lights, Camera, Code. Return types and outputs, we're learning about that now. And we learned about that with Sonic Workshop. Classes and components, and it's all about putting it together. And you can see we've got some images down here of our Flashy Photos and Lights, Camera, Code. And you might remember putting components onto the screen. And then we talk about going further. So building apps in Swift, coding clubs, Everyone Can Create. Lots of different directions we can go when we're all done with this material. So we might start exploring that book a little bit in the very near future. But what we're going to do today is we're going to jump back to our Sensor Arcade. And actually, before we leave that, there's one other. So there are a few books launched yesterday. So in addition to this Everyone Can Code Adventures, which is aimed kind of at our group, who's been working through the last few months in all this coding at home stuff, there's another section. So if we go back to the library, we can see this section here. It's called Develop in Swift. And there are a few new books out. This Develop in Swift Explorations is a bit like Intro to App Development with Swift, just with the newer version of Xcode, some new ideas and some interesting new wrinkles in how the material is presented and what it means to be online and where, what does your data do? Who can access it? Develop in Swift Fundamentals aligns to the App Development with Swift course. This is a good one for learning how to build an app from scratch. It takes some of the material that we learned in Everyone Can Code Puzzles, and it really builds on it and gives you a good foundation for building apps in Swift for the iPhone, for the iPad, for Apple TV, kind of endless directions you can go in there. If you're in the US, there's a Develop in Swift Advanced Placement Computer Science Principles class that's very like the Develop in Swift Explorations. You learn a bit about computer programming. You learn a bit about how you might design an app. It's great. It's a great series anyway. And there's also teacher guides. So if you're an adult following along and you want to try to teach this to, whether if you're a teacher, to your students, or if you're a parent to your kids, the teacher's guide give you great insights into how to teach it in different ways. So you can simplify, you can extend if somebody's really shining in a particular example, or you can make people collaborate. So if you have a couple of students together, you can get them working together, which is what we often have to do as developers. So that's my plug for the new material that just came out yesterday. I think it's great stuff. I think we're going to do a lot with Everyone Can Code Adventures over the next few weeks and months. And should be a lot of fun. All right, so all that talking has given us plenty of time to download Playground. So I'm going to open that up. And we're going to dive right back into Sensor Arcade. Nope, or we're not if Playgrounds doesn't open. We'll try it again. All right, here we go. So right back into Sensor Arcade. Remember, we grabbed that from the challenges section in the More Playgrounds feed. So we're on Sound Poppers. You might remember that yesterday we did Dashing Donuts. We implemented a couple different light updates, the way we would handle the brightness that was being passed in. We set a label that we could see what the red component of the light being passed in was. And I didn't do particularly great in my Dashing Donuts high score. I got kind of I think I got what, 60 something meters, and then I collected 4 donuts, which isn't great. So hopefully you did better than I did. What we're going to do today is we're going to go to the next lesson, and we're going to go to Sound Poppers. So it says the goal here is Poppers 2 to 7 all move together. And it tells me here that Sensor Arcade would like to access the microphone. So we'll say OK. So we need to edit the code to get them all moving one at a time and win the game. So how audio works. So we're going to create an instance of Tone Sensor. We're going to by doing that, we're going to tell the device to start collecting 2 types of data from the microphone, pitch and volume. So we're going to run our code and try whistling or making some noise. Notice the pitch and volume changing. So then step 2 is we need to break up the last if statement. So each popper, 2 through 7, does something unique. So we're going to use the code in the handle tone update function as a guide. And we're going to explore using both tone.pitch and tone.volume to control the poppers. So that's the two properties there. And to see code examples, we can check out the hints. So let's see. So here we are. We create our tone sensor here. And then we have this handle tone update function, which takes a tone object as a parameter. And we have an if statement straight off the bat. It says if the tone volume is greater than 0.03, then we're going to run all this code. So if it's very quiet, we won't run any of this. And then later we set the on update handler for the tone sensor to our handle tone update. Well, let's try running it and practicing and see what happens. And then we'll go through the rest of this code. So hit run. Like we did with the other ones, we're going to practice first. So the goal here is to pop the balloons while avoiding the bombs. Use the tone sensor to move your poppers. Okay, let's practice. So it's very quiet. They stay down at the bottom. But then when I talk, our little poppers fly up. All right, so we want to avoid the bombs. And we want to move everybody up so that we can smash the balloons. And you can see my pitch is there and my volume is there. So if I whistle, the pitch goes up pretty high. But if I'm talking, it stays relatively low. All right, so we need to monkey around with this a little bit. And you can see here that this is where, just like we had yesterday, we had a way to play around with our light input. If we tap on this, if we tap on it and expose it, we can actually change the sound in volume and pitch. Okay, so let's see what's driving these guys. So we've got, if the volume is greater than 0.03, that's when we start executing this code. So we say, okay, well, if the tone dot pitch is greater than 200, and the pitch is less than 399, the first popper in our array, so we have an array of poppers here, we apply an impulse to it of 0 on the x-axis, but 150 on the y-axis. If the tone pitch is greater than 400 and the tone pitch is less than 599, then we apply an impulse of 150 on the y-axis to the second item in our array. And then if the tone pitch is greater than 600 for all the other poppers in the array from 2 to 7, so the third one down to the very end, we'll apply an impulse of 130 on the y-axis. Okay, so our goal here is to apply a different one. Let's see, edit the code to get them moving one at a time and win the game. So we have to do it one at a time. So let's check out the hint and see what we might do for that. So it says each of the great gray spikes is part of the poppers array, right, with an index from 0 to 7, okay. This shows us how to apply an impulse to a specific popper. So we use the index number inside the brackets like we did here. So we loop through, well, here we loop through our poppers, and for each one, we apply an impulse from 2 to 7. So let's see. So it says bonus here, instead of writing an if statement for each popper, try using tone and pitch and tone volume in a range to call on different poppers. So they have an example here. And we did something like this. We used a bit of math in our previous pages to generate our X and Y direction values. Right, we used in the Sonic Workshop, we used the hue of the image. We did a bit of math on the hue of the color that we had to change what color was showing where we touched on a particular graphic. And we can see here that they've done a bit of math to say, okay, cool, well, if the pitch is greater than 40 and the volume is greater than 0.008, then they determine the popper index by doing a bit of math. So they take the tone pitch, they divide it by 1500, and then they multiply it by 7. And they say if the popper index is greater than 7, they just set the popper index to 7. That's one way of doing it. Will we try writing that code? Let's try using that code and see if that doesn't work for us. So what we're going to do is just copy it in as it is. So we'll say, so in the tone update, we'll say if tone pitch is greater than 0.008 and the tone volume, so tone.volume is greater than oops, sorry, we're gonna have to change that pitch. 0.008 for the volume, and for the pitch we're going to actually change that to 40. We're going to delete the rest of the code in here. We can always reset the page to get our code back. So far we've written this line here. Now we're going to create an variable like they did. So we'll say popper index, and we'll set that equal to, we'll do this bit of math here, and we create an integer, so we do int and so we need to put another open parentheses because we want these operations, the tone pitch divided by 1500, to be done together. So we'll open up another one, so we'll do tone dot pitch divided by, so this slash 1500 multiplied by 7. So now I need to get on the other side of this parentheses. I'm going to hit the star times 7. And then we just do our little check. Now, we can try leaving off this check here. They have a check where they say if popper index is greater than 7, set it to 7. Let's leave it off and see what happens. So then what we're going to do is apply the impulse to that popper at that popper index. So remember, in an array, we have an array called poppers. In an array, you access an element in an array by using the square brackets and then passing in a number. So let's say, oops, we don't want to do equals. We want to actually apply an impulse to that one. There, we'll pick it out of the autocomplete. So apply impulse. X is going to be 0 because we only want them to go up and down. And then Y is going to be 150. Let's try running that and see what we have. We'll hide the volume control. And, oh, we had our first crash. Now this is why this index out of range, you might remember that from our arrays chapter way back in Everyone Can Code Puzzles. This is the reason why they have that check, to see that if the popper index is greater than 7, we know that there are only 7, 0 to 7, so it's 8 items in our poppers array. So here we'll make a little check. So we'll fix that. So I'll tap after the line where I get my popper index. In fact, let's expand that so we can see. So I have my popper index variable. So before I use it on my array, I want to create an if statement. So I want to say if popper index, and I'm actually going to try to be a little bit smart here and say if the popper index is greater than, and I'm actually going to try to use the count of the items in the array. You might remember on an array we can access the count property and it'll tell us how many items are in the array. So for this one, which has items at indexes from 0 to 7, there are 8 items in the array. So we'll say poppers dot count. That's throwing an error, that's fine. And we'll do -1. Because the count of the array is going to be larger than the index that we can use. So now if it's larger than the end of the array, we'll just set the popper index to 7. Because that's the last item in our array. Let's try running our code and we'll see if that's fixed things and we don't have a crash while we're running anyway. Well, we seem to have, let's hit run our code. Here we go. There go a couple. 1 and 2 are pretty popular. The other ones, I can't seem to get the higher ones to go. Maybe if I whistle. I'm still struggling because I'm not able to get those 4 with 3, 4, 5, and 6. And I also managed to pop a bomb, which isn't great. All right, so we have to fix that. So let's see. We'll try stopping that. We'll try running it again. Okay, so we'll need to figure out a way because the bombs actually change. So every single time we restart the playground, the bombs and balloons aren't always in the same spot. So let's figure out, let's write one little extra bit of code. I'm actually going to delete this code. We won't use that one. We'll hit reset my page. I like that hint. It's not bad. But how are we going to get these? How are we going to alternate? So that was another way to switch. So based on the pitch and the volume, we could switch which which ships we launch there, which ships we shoot up. How are we going to get these? We could add a bunch of other else ifs here to iterate through our poppers. Let's run our code and see what this looks like again. And we'll play with the volume. We just need to get those guys operating independently. So let's see. So let's change this. So instead of being a range, we'll actually just apply the impulse to 2 here. Let's see. Because what's the range of our pitch? Our pitch can go from 0 to, what's the highest? So 3,000. Almost 4, well, probably, I'm guessing 4,000. Okay, so we can play with that. So if there's any kind of sound from the tone pitch from 600, I'm going to use my space bar to get in here and add an additional condition. So if the tone pitch is greater than 600 and if the tone dot pitch is less than let's see, so we did 400 to 599. We can do 799. And we can just keep going up this way. We can apply the impulse to the popper. So I'm going to tap on my for loop and delete that. So we'll do poppers. We have to access our item at index 2. Apply impulse. So 0 for the X and say 150 for the Y. If we tap on here, we can add another else if statement. So we could do something like tone.pitch is greater than, and I'm just grabbing that from over the G. So if it's greater than 800 and less than, tone.pitch is less than 999, then we'll do, actually what we're going to do is we're actually going to tap on this guy and select his text. We'll copy that whole line and we'll paste it down here. And we'll do it again. So we'll add another else if statement. We'll do tone.pitch is greater than 1000 and tone.pitch is less than, let's say, 199. Nope, that's not going to be right. 1199. We're going to paste it because it's still in our paste board there. We'll set that to 3. Let's see how this is going so far. Let's hit run my code. There we go. There are all of our ships. Now we shouldn't see anything. We should see okay, so we're going to have to work on our range pretty carefully because it's tough to make a noise at its very specific level. So we have to kind of play around with our little helper bar here. But let's keep going. Let's keep going. Let's try adding in a few others. We'll add another else if statement. We'll do tone.pitch is greater than 1200 and tone.pitch is less than the next number up. So let's see what that's going to be. That's going to be 1399. And maybe we want to give bigger ranges here so it's a bit easier to get to our value. We'll paste in on this code again. Now we're on poppers at index 4. Oops, not R, 4. We'll add another else if condition here. It's greater than, what's the next number going to be in the series here? It's going to be 1400. And we just grab the double ampersands from over the S. And tone.pitch is less than 1599. All right, and this is going to be our fifth. We're almost there. If tone.pitch is greater than 1600, and you can see that we're just going up by 1 so that we kind of get all the ranges. We have about 200, whatever that value is in pitches. I'm not sure what that measures, but 200 in that pitch range that we cover each time. And tone.pitch is less than 1799. This is going to be our sixth one, so we're almost done. We'll close the square brackets and we'll add one last else if statement. But actually, we don't need an else if statement. We could actually have an else statement to end it all because we only have one more item to add. So let's do that. Let's add an else statement. We'll paste in the code and we'll change that index from 2 to 7. So that's the last item in our array. And now let's try running our code. So now if we play around with our sound down here. Okay, we have them all going independently. So that's a lot of code, and it was a lot of pasting, which isn't always great. But this is a good way to solve it the very first time. So let's play our game and let's see what our high score can be. So we'll hit play. 3, 2, 1, here we go. Oops, we hit a bomb. Oh boy. All right, well, so we'll try again. All right, we got to stay kind of quiet. Now the problem I think was that seventh one was the one that got us. Now I'm going to use the little toolbar down here at the bottom. If you don't have it, you can play with it up there. Oh, hit a bomb. All right, we can try again. 3, 2, 1, here we go. All right, 7 is easy to get up there because it's the else statement, so it gets called the most frequently. So we'll start down here for the rest. So if we play with our volume control. All right, we did it. All right, we won. Hopefully you can beat that score. It's much easier when we have the little sound control to play around and generate a sound with certain pitches. When you move your finger over it, of course, up is going to change the volume, and then across is going to change the pitch to greater. So we know that we want to avoid the pitch ranges where the bombs are. And we know the pitch ranges where the bombs are based on these numbers in this huge else if block that we wrote. So that was kind of cool that we've got our microphone hooked up and we can react to the pitch and the volume that we receive in from the microphone. Tomorrow we're going to do something that's super useful in games and that might remind you of not tomorrow, tomorrow's Saturday. Monday, we're going to do something that might remind you of our App at Home series where some of you built your own games. We're going to look at collisions and what happens when two of these different graphics here, or sprites, actually collide with each other on the actual scene. We'll get some notifications then, so we'll be able to handle them like we did with the bomb. When we collided with this bomb, that's when we got the "you lost" message right away. So we'll play around with that on Monday. Have some fun with your Sensor Arcade. I'd love to see some high scores from Dashing Donuts, from Catching Cupcakes, from Sound Poppers. I'd love to see some code that even improves this. Maybe you follow the hint that they had and you use the pitch to change which popper you're moving at any given time. Give it a shot, and we'll see what you come up with on Monday. All right, happy coding. Remember to like and subscribe.